since in this screencast we are going to talk about workflow generation, we go with the first option, and then in the intro example folder, you can select the multi-hit as an just example and demo, which model the absorption energy workflow in YAML or format, and you can just select one of these versions, which are different solution to the same problem, and I go with the workflow underline version underline 1 YAML in YAML format. And since I just chose the version 1, I also select the input path accordingly, and in the inputs folder there is 3 different version. I just go with the first version and just select it as an input path. Please be aware, you shouldn't choose any of these files, but just the path to this folder that contains all your files necessary for constructing your workflow. These are the raw data for your simulation. Okay, and then in this drop-down menu you can select different workflow management system. In this example we are going to generate a SimStack. Then simply just run the run wfGenes in order to generate necessary files for SimStack and visualize the graph related to this workflow. This is absorption energy, and okay, and also wfGenes in this GUI gives you the exact absolute path to the generated output by wfGenes. You can navigate to this address to this path easily with this again in the intro example folder in the multi-hit and wfGenes output and energy slab version 1. There is a dot folder which is the graphs, and that can be used for presentation or publication, or also SimStack folder which contains necessary files of vanos and the whole workflows, and even a template of the resource configuration. As you can see, this example has like 9 vanos, workflow active nodes, vanos in the SimStack workflow management systems. And if you navigate to this folder, you can see also there is resources files that just offer a template and set the defaults of the required resource for this simulation. That can be easily also set up through this file for each vano separately, or using the SimStack GUI, which I do not cover how you can work with SimStack in this screencast. And okay, in the same manner also you can generate different workflow management system for exactly same wconfig. You can have a look to the wconfig by just pressing edit wconfig. This is the construction of the wconfig, and you can just modify and see how the graph changed, save, and however it is easier to use the GUI, but also I suggested to just navigate to the folder of the wconfig in each example. For example, for multi-hit, it is these are the wconfigs. You can just open up a YAML file and see how you can choose to select these and also modify and generate the graphs. And all examples here have the same similar pattern and similar tree. There is a lib folder, there is configuration files, and if there is a necessary input, like for example multi-hit, or for each example, you can just have a look into the necessary inputs for your simulation or workflow construction by navigating to these folders. Okay, In order to recap, constructing and generating necessary file for your workflow using wfGenes is provided by simply a few clicks. It is necessary to just constructing your vconfig and then pointing out to the input path and the vconfig using the GUI. And then you can later just use the workflow execution using fireworks, task or parcel, but which is not in the scope of this screencast. But yes, that was all in regarding to generation of workflow using wfGenes and graphical user interface. Thank you for your listening. I hope it helps your research and your PhD.